Alright, today we're doing lesson 5-7, solving quadratic inequalities. And we're going to be taking our quadratic equations then, and we're going to be doing two things with them. We're going to be graphing the solution set and shading like we did with absolute value and linear models. And then we're going to be looking at quadratic inequalities. In other words, a statement where it's greater than or less than or equal to 0. And we're going to be looking at graphing our solutions on our number line, writing them as a compound inequality, and using interval notation. So we're actually going to be doing all three of those things for this lesson. So first of all, we're going to go ahead and start. So first of all, if we have a quadratic inequality in two variables, then it's going to look something like one of these. One of these four possibilities where we have y is less than the quadratic function, y is less than or equal to it, greater than or greater than equal to it. One thing to remember then is if we have less than or greater than, just like with our linear or absolute value ones, we will use dotted lines to represent them, the function. And if it's less than or equal to, greater than or equal to, then we're going to use solid lines when we graph. So when we do graph, we have a couple of rules here. First, it says to graph the parabola that defines the boundary. And we use, like I just said, a solid line if it's less than or equal to, dashed line if it's just greater than or less than. And then we'll shade above the parabola when it's great or, and below the parabola when it's less than. And I'll show you how we're going to use a point to be able to determine that also. So here we have y is greater than or equal to x squared minus 7x plus 10. And this is an equation where you could just graph it in your calculator, or I'm actually going to use my equation editor here. And we have y equals x and squared minus 7x plus 10. So I have just the function there that I'm going to work with, and I'm going to graph this function. Since it's a solid line, I'm going to go ahead and graph it. And I know that on this line that I do have a y-intercept of 10, so I'm going to go ahead and mark that point on here just to help me out because sometimes it kind of graphs funny. So I'll pull this over here and draw our graph. So here's our graph of this function. And because it says greater than x squared minus 7x plus 10, that means we're going to actually shade in the middle. But I want to talk about using a point just to test it. And if you remember, whenever we use the point to test to see whether something was true or not, we use the point 0, 0. So we're going to test to see if it's a true statement or not for the origin. So I'm going to go ahead and put 0 in here for y and see if this is a true statement. And so let's see. I have 0 on the left side, and 0 squared is 0. 7 times 0 is 0, so we have 10 on the right. So is 0 greater than or equal to 10? And that is a false statement. And since the point 0, 0 is outside of the graph, that means then that our shading that we're going to do is going to be on the inside of the graph. So I'll go ahead and use the highlighter here. We'll go ahead and shade this in yellow. Alright, so I got everything inside that quadratic function that's shaded because it tells me that those are all the possible solutions. Everything inside there is a possible solution, and so I have to shade that whole thing there. And that would be all that is then. And so you could graph it on your calculator. Put in here, you could find the vertex point, y-intercept, and your other point, and graph them that way also. Basically, it's up to you which way you start and graph. Okay, so we'll go ahead and go on to example 2 here. In example 2 then we're actually going to be solving equations. And we're going to do 3 things, like I said, with these equations. That we are going to put our answers on a number line as a compound inequality and in interval notation. So if you remember interval notation, we use parentheses if it doesn't include the point, and a bracket if it does include the point. So if we had x is greater than 3 and less than or equal to 5, then we would use that interval notation right there. And if I graph this on a number line, we'd have 3 here and 5 over here, and open dot on 3, close dot on 5, and then connecting them. So we're going to use all 3 of those things in our answers for this problem. So the first thing we want to do is we always, when solving a quadratic inequality, quadratic equation, we always want to get it equal to 0. And then, sometimes we can use like tables and graphs like it says here, or we can use factoring if that's possible. So first thing I'm going to do is I'm going to go ahead and subtract the 5. And I'm actually going to show you how to do the factoring part of this right away. And if you want to use the graphs or tables, you can do that just by plugging them in your calculator, but I think it's a lot easier to do it this way. So what we're going to do is we're going to factor, and we're just going to find the zeros first of all. So we get it equal to 0. So number 1, we want to get it equal to 0, or get an equality equal to 0. And number 2, then we want to factor it to find the zeros. And then the third thing is we're going to graph on the number line the zeros, and we're going to put them on the number line with open dots for greater than or less than, and closed dots if greater than or less than or equal to, or greater than or equal to. Okay. And then we'll determine, then the last thing we're going to do then is our fourth step then, is we'll determine where to shade on the number line. And then lastly, we'll do our final answer. So which will be in interval notation or and a compound inequality. So let's go ahead here and we're going to do those 5 things. So we're going to factor this now. X plus 3 and x plus 5. And we want to know when that's greater than or equal to 0. So we're going to go ahead and make our number line now. So, and here's our so we got that. And let's see, here we're going to have x equals -3 or -5. Right? So we're going to go down here to -6, and then -5, and -4, and -3, and -2. You just need to have 1 on each side of those zeros we have. Now since it says greater than or equal to 0, we're going to go ahead and I'm going to use a different color here. We'll use the blue. we're going to put closed dots on -5 and -3 because of the greater than or equal to. Now we need to determine where we're going to shade on this number line. So we need to know, are we going to shade in here between, or is my shading going to be out here and out here? Excuse me. So it's either between or it's on the outside. So what I'm going to do is I'm going to check my favorite number over here, which is 0. So we would have -1 and then 0. So I'm going to check -1. If it's true for -1, then that means it's going to be in this area here and this area down here. We have the red lines, our red arrows. And if it's false, then it's going to be in this area here where the blue arrow is. So we'll go ahead and put 0 in here. So we get 0 plus 8 times 0 plus 20 is greater than or equal to 5. So these two parts are 0. So is 20 greater than or equal to 5? And that is true. So that means our shading is going to be in the red areas. So that means we're going to go this way out here because it's true out here, which means it's not true between them. So then it's true out here also. So we have to go both directions. I got to shade that completely. And then I'm going to write my compound inequalities. So there's my answer on the number line. So now this is going to be from -infinity to -5 with a closed, with a bracket, or from -3 to +infinity, and that would be a parenthesis. So then when I write it as a compound inequality, though, we have to write it this way. So we have, as a compound inequality, we're going to have that x is less than or equal to -5, or x is greater than or equal to -3. So we have all three of these answers, and all three of them represent the same thing. So let's go ahead. Okay, so let's go ahead and look at this other example here, which is very similar to the one we just did. The only difference is that we have less than instead of greater than or equal to. So when I go ahead and solve this, I'm going to end up in the same situation, and we're just doing the second one just to show the difference between with the greater than and the less than. So here we've got, we'll take our 5 and move it over. So we're going to subtract 5 from both sides. We have 15 here. And our factoring again, x plus 5 and x plus 3. And so we're going to get -5 and -3 again. So we take and make our number line. So here's our number line. No, that's not what I want either. Where is it? Let's do this one. Here we go. There we go. No, that's not. Well, anyway, let's get rid of all those things. Let's just draw this. Here we go. Okay. So we've got our -6, -5, -4, -3, -2, and we're going to go to 0 again. All right. Now, because it's less than, that means we're going to put open dots instead of closed dots at -5 and -3. And once again, we're going to check 0. Okay. Is it true at 0 or not? So we put 0 in here, and we get 0 squared plus 8 times 0 plus 20. Is that less than 5? And that is a false statement. So since it's not out in this area here, because that's false, that means it has to be in this area here. Now, we could check that. So let's go ahead and check it. Let's use 4 and check our answer. So we take our calculator, and let's move it over here for a second. And we take 4 squared plus 8 times 4 and plus 20. Oops, there you go, I messed up here. That should be negative 4. So let's try negative 4 and square that. Plus 8 times negative 4 and plus 20. And is that less than 5? And it's equal to 4, so it is less than 5. So then that's a true statement between these points. So my answer is going to be between them. So I'm going to have this area, like I did here, shaded in. Okay? So there's part of our answer is the number line. And then, so we're going to write it as a compound inequality. So that would be that x is greater than negative 5 and less than negative 3. And remember, you put the variable in the middle, and the greater than on the left, the less than on the right, with the smallest number on the left and the larger number on the right. And then as integral notation, we're using parentheses because it does not include the number. Put negative 5, negative 3, and then we are done with that one. And that then tells you how to use factoring. But the biggest thing is factoring it. We find our zeros, put them on a number line, and then determine, okay, is the shading going to be between the zeros, or is it on the outside of the zeros, to the right and to the left of those zeros? And once you figure that out, then you can write the compound inequality and the integral notation.